Hello everyone, welcome back to Tales of Chemistry. Today, let's learn what are alkanes and how can we name alkanes. So, alkanes are hydrocarbons. What is the meaning of hydrocarbon? They contain only atoms of carbon and hydrogen. No other elements are present. Atoms of no other elements are present. Just atoms of carbon and hydrogen are present in hydrocarbon. So, alkane is one such hydrocarbon having the general molecular formula CnH2n plus 2. Now, what is the significance of this general molecular formula? Once you learn the general molecular formula, you can find out the molecular formula of any member in the homologous series of alkanes. So, say for example, if you take n is equal to 1, that is just one carbon is present, then substitute n is equal to 1. So you get C1H2 into 1 plus 2, that makes it CH4. Another example, the second member of alkane homologous series, alkane family, C2H2 into 2. In the place of n, substitute 2. 2 into 2 plus 2, which is C2H6. Third member, same way, n is equal to 3. C3H2 into 3, 6 plus 2. C3H8. So, if we know the general molecular formula, the formula of any member in the homologous series of that particular compound can be obtained. Now, second property regarding alkane that we must know, alkanes are saturated hydrocarbons. Saturation meaning, or the word explains that there are only single bonds present between the carbon atoms in any alkane. You won't find any double or triple bond in alkanes. That's what they are called. That's why they are called saturated hydrocarbons. Now, because of saturation, they don't have the tendency to react, or I must say they react very less, or only certain reactions like substitution, oxidation, these kind of reactions take place, not any addition reactions take place here with regard to alkanes. Okay, so alkanes are called paraffins because they react less affinity. How can we name this alkanes? Alkanes are named, simple alkanes I mean, to begin with, root word plus primary suffix. Now, primary suffix is depending on the name of the homologous series. So here the name of the homologous series is alkane. So the last three letters of alkane, ANE, is taken as the primary suffix. I have written 5 examples here. All of them, or any other member of this homologous series, if you consider, the word will end with ANE, and that ANE is called primary suffix. Now, from what are we getting the root word? A root word is written based on how many carbons are present in the given example, given compound. Suppose the parent chain. I'll explain what is parent chain little later. So if you find one carbon, then the root word corresponding to that is meth. So your compound is now methane. If you have two carbons, then the root word is eth. For three carbons, the root word is prop. For four carbons, the root word is but. And finally, for five carbons, the root word is pent. So the syllabus here tells us only up to five carbons we need to study. So meth, eth, prop, but, pent are the root words. Moving on, let's take certain specific examples and study. First one is methane. I mean, CH4 is the formula. Okay, this is the molecular formula. The same molecular formula can also be written in a detailed way, meaning show the carbon. Carbon is tetravalent, so represent the four bonds and connect all the four hydrogens around the carbon like this. So this is called the branched structural formula. Okay, so CH4 is the molecular formula. When you show all the bonds present in CH4, it is called the branched structural formula. Now, once again, when you put them together per carbon, so here only one carbon is there, and on that carbon there are four hydrogens, CH4. This is called condensed structural formula. Now, it's not always molecular formula and condensed structural formula remain the same. No. In the case of methane, it so happened that the molecular formula and the condensed structural formula are one and the same. Now, how do we name this? I have already told you the name is methane, but let's see. There's only one carbon. Therefore, the root word corresponding to one carbon is meth, and it is a saturated compound. When there is only one carbon, the question of between carbons, do you have a single or double or triple bond? That concept is not even arising because you have only one carbon. Therefore, straight away, let's write ANE, which gives us methane. So, the first member of alkane homologous series is called methane. Its formula is CH4. Second member, C2H6. Let's first of all write the branched structural formula. How do we do the branched structural formula? You need to write the two carbons present. Since it is alkane, connect the two by a single bond. Each carbon is tetravalent. One bond is represented here. So three other bonds are done like this. For the second carbon also, one bond is already represented. The three other bonds are represented here like this. Now, fill it up, satisfy all these valencies by hydrogen. So this is the branched structural formula. When you write the condensed structural formula, you need to individually write the carbons. Write the carbons separately. So C single bond C. On the first carbon, you are finding CH3. So write the hydrogens here like this. Second carbon also contains three hydrogens. So once again, CH3. CH3 single bond CH3. Two carbons are there. So eth, single bond between carbon ane, put them together, ethane. So the second member of alkane homologous series is ethane. Now, the third member, three carbons. So in the structural formula, branched structural formula. I'm representing all the three carbons, connecting them by single bonds. First carbon, let me call this as the first carbon. It has formed only one bond. So three more it should form. So out of 8 hydrogens, I have already written 3 hydrogens here. Second one. Second carbon or the middle carbon, it's already bonded with the 2 other carbons. So I need to draw only 2 more hydrogens on it. Carbon is tetravalent. Carbon cannot form more than 4 bonds. Last carbon, 1 bond is formed. So we need to represent 3 more bonds on it. So this becomes CH3, CH2, CH3. This is the branched structural formula. Condensed will be the first carbon, 3 hydrogens, CH3. Second, 2 hydrogens, CH2. Third has 3 hydrogens, CH3. So CH2, CH2, CH3 is the third member and we call it prop plus ANE. Prop representing 3 carbons, ane representing the single bond. Therefore, this particular example is called propane. Moving on to the next, C4H10. Let's first complete the branched structural formula. So I'm writing all the 4 carbons in a straight chain, assuming that they are all connected in a straight chain. Now, connect them by single bonds. Carbon number 1, 1 bond is formed. So 3 more bonds need to be formed. Second one, 2 bonds are formed, therefore 2 more bonds need to be formed. Next, 2 bonds are there, so 2 more need to be formed. Last one, finally, 3 bonds. So, this is the branched structural formula and the condensed will be CH3, single bond, CH2, again a CH2. So, single bond CH2 and then you have CH3. 4 carbons, so root word is but and primary suffix remain the same, butane. Then C5H12. In C5H12, you have 5 carbons. So write them all in a straight chain, assuming that this represents a straight chain compound. Connect them all by single bonds and then fill up the other valencies or satisfy the other valencies remaining with the help of hydrogen. So you get the branched structural formula like this, and the condensed formula will be CH3, CH2, 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 CH3. 5 carbons, pent, primary suffix ane. So name of this example is pentane. Now, moving on with the branched hydrocarbons. All this while, all the examples that we have taken are straight chain compounds. Wherever I had a possibility of writing a branch, I told you, right? In the case of C4, when there were 4 carbons, I said, assuming the 4 carbons are in a straight chain. Now, see here. Look at this compound. This also contains 4 carbons and 3 plus 3 plus 3, 9 plus 1, 10 hydrogens, exactly like butane which we discussed. But the arrangement of carbons are different. Here, three of the carbons are in a straight chain, one carbon is appearing as a branch. So these kind of compounds are named in a slightly different way. So here there is a task of finding what is the parent chain. Now, what is the parent chain? You need to look for the longest possible carbon chain. Okay, now one more speciality is this carbon chain has to be continuous. So, longest possible continuous chain of carbon has to be selected. But how do we do this? Well, so start from either the left or the right side. Number, suppose I'm now starting from the left side. Number the carbons. Okay, this is my first carbon. Now, I can move on to the next carbon provided there is a bond. And I'm finding a bond between carbon 1 and carbon 2, the next carbon. So, I can count the next carbon as the second carbon. Now, after reaching the second carbon, I have two options. One, I can move straight. Second, I can take a right turn. Now, the beauty of this structure is whether I go straight or I go to the right. If I take a right turn, I am getting only three carbons. So let me move straight. Let me call this as the third carbon. So the parent chain has only three carbons here. The fourth one, this one, is not included in the parent chain. So we call the one which is not included in the parent chain as the locant or the substituent. Or simply you call it the branch. And CH3. Now you need to find out a name for CH3, right? CH4 is called methane. CH3 is obtained by removal of one hydrogen from methane. Removal of one hydrogen from methane. Therefore, CH3 is called the methyl group. Well, so the substituent or the locant or the branch here is called methyl. Now, once we get this, okay, you need to identify, once you get the name, you need to identify the position of the methyl group. Where is the methyl group present? Methyl is present on the second carbon. Second carbon contains the methyl group. Okay, so here name of this is 2 hyphen. This hyphen is compulsory. It is suggested by IUPAC. So you must write this 2 hyphen methyl. All small letters are used without leaving space. Write the name of the parent. Parent has 3 carbons. So prop, single bond between carbon, propane. So this particular example is 2-methyl propane. 2-methyl propane. Okay, now let's move to the next example. Here, let me write CH3C, one CH3 here like this, one more here. Okay, altogether you have 5 carbons, but that's not the case here. 5 carbons are there, but I cannot call this pentane. Instead, I will have to check how many carbons are present in the parent chain. So, like the previous example, let me start numbering. Let me call this number 1. there is a connection from this to the next carbon. So this is obviously the second carbon. From here, I have three choices. I can go straight or take a left or take a right. But whichever route I take, there are only three carbons. So for a change, let me now move to the right side. I could have gone straight, but I just want to tell you that that straight chain is not the requirement. Continuous chain is the requirement. So now this is my parent, and parent is still having three carbons. Therefore, the name of the parent is propane itself. And the substituent or locants, there are two locants, right? Both of them are methyl. I cannot combine them and call it C2H6. No, these are two separate methyl groups that I have. Okay, so two methyl groups. Where are they present? Both are present on the second carbon. Both of them are individually present on the second carbon. Therefore, when I name them, I will have to first write the position of the methyl group. One is present on the second position, comma. Second methyl group is also present on the second position itself. Two times I will have to write 2. 2, comma 2. First methyl is on the second position. Second methyl is also on the second position. 2, comma 2 dimethyl, and then the name of the parent, propane. 2, comma 2 dimethyl propane. Okay. Next example. So I'm including one extra carbon here. Task number 1, find out the parent. 1, 2. Now, if I take the right turn, I'm including only 1. But if I go straight, I can include 2 more carbons. So there are 4 carbons in the parent chain. This one appears as the substituent. It is present on the second position. Therefore, this is 2-methyl and the parent butane. 2-methyl butane. Suppose if I write one more methyl on the same position, let's see. CH3, C, CH3, CH3, CH2, CH3. Carbon 1, 2, 3, 4. So once again, the parent is butane. You have a CH3 on the second position, another CH3 on the second position itself. So 2, comma 2 hyphen dimethyl. 2, comma 2 dimethyl butane. Like here, 2, comma 2 dimethyl propane. Suppose the structure was written like this. Okay, now if I start numbering from the left side, 1, 2, 3, 4, the methyl now comes on the third position, right? But this way of numbering is wrong. Why is it wrong? So after finding the substituent, your second task is to give the lowest possible number. Give the lowest possible number to the substituent, meaning when I move from left to right, the methyl was on the third position. But if I number it the other way, call this as 1, and this 2, this 3, and this 4. The same methyl is now on the second position. So lowest possible number for the methyl is 2. Therefore, this is the correct way of numbering. Move from right to left in this case. So always you should see which way of numbering is correct so that the smallest, lowest number is given to the substituent. Okay. Now, the name of this, 2-methyl butane. Similar to, not similar to, same as this. This example, 2-methyl butane, and the one which we discussed now, both are one and the same. Only thing is, the arrangement of methyl group was different here. From the previous one, we had to number from left to right. Here, we had to number from right to left so as to give the lowest possible number to the substituent. Moving on to the next example, CH3. Suppose I have a methyl group here and a methyl group on the next position. Numbering has to be continuous, meaning if you start from here, 1, 2, 3, 4. You cannot stop 1 and 2, then again move from right to left, calling the right carbon as 1 and the second as 2. So, I mean, 2 first carbons and 2 second carbons. No, that's not allowed. Once you start numbering, continue with the same numbering. 1, 2, 3, 4. Okay, even if you go from right to left, 1, 2, 3, 4 does not make any difference. The methyl groups are present on the second and the third position respectively, whichever numbering you select. So both ways of numbering are correct. And here the name of the compound is 2, 3 dimethyl 2, 3 dimethyl butane. Few more examples. Let me now write 5 carbons. This one. Let's quickly number them. 1, 2, 3, 4, 5. No explanation needed. Why left to right and why 5 carbons in the straight chain, in the parent chain. So second position, you have methyl. So this is 2-methyl, 5 carbons, pentane. Now, if my example was this, we continue with the same numbering. 1, 2, 3, 4, 5. Second and third positions, you have the methyl groups. 2, 3 dimethyl pentane. Next, suppose if I had numbered them like this, your numbering technique will change. You will start numbering from here, 2, 3, 4, 5. So this is again 2, 3. So same compound, 2, 3 dimethyl pentane. Last example, suppose you have CH3 here on the third and on the fourth position also. You have CH3 groups. So 1, 2, 3, 4, 5. Second third, fourth position. Totally 3 methyl groups. So trimethyl. 2, 3, 4. Trimethyl pentane. That's all in this video. Stay tuned for more videos. Thank you.